Hi, in this video we're going to look at properties of logs. I'm going to show you 3 different properties and how we can condense into using those properties and then expand logarithms using those properties, as well as some evaluating. In the next video, it's just going to be a brief video with one example of solving exponential equations using logarithms, so that will be in the next video. And that's where we'll see this come into play. All right, so we have log A plus log B is equal to log of A times B. Log of A minus log B is equal to log of A divided by B. And log of A to the x power, we can just bring that x out front, and it's x times log of A. A couple of things to note here. This only works if the base is the same, so it has to be, if you had a log of base 5 plus a log base 3, you could not use these. The other thing to note is that if you see a logarithm, if it's log of something and you don't see a base, it's understood to be 10. So that is understood to be 10. All right, so we're going to use these properties to condense. So notice that this is plus here, so we're using this rule. So we can condense this into one log. It's going to be log base 8, whatever that base is, of A times B. So 3 times 4, which is 12. And that's it. That's as simple as it is. So it's just using these logarithm properties to condense. This one's subtraction. So this is going to be condensed as, and again the base is going to stay the same, so it's going to be log base 6 of 15 divided by 5, which is log base 6 of 3. So we're just condensing those. All right, fill in the blank. Log base 2 of 27 equals blank log base 2 of 3. This is using this rule where we have something times that. So we want to basically know, if you look at this, log base a to the x equals x log a, we basically want to know what power we're using here to get 27. So we can kind of rewrite or think of this 27 as 3 to the 3rd power. So I'm going to rewrite that 27 as 3 to the 3rd, because if you notice in the formula, this is A, and A. So these two numbers have to be the same. It's this that could be different. So this 3 is coming out front, and that's what we're putting there. So you can just rewrite it in terms of an exponent, and then bring that exponent out front. So that's using that rule. And we'll see that again in a little bit. So in the next one, this is also using another interesting observation, which is kind of a property as well, that notice that you have 2 ln e to the 6th. We're going to see a relationship between this ln and e. They're actually inverse operations, so they undo each other completely. But before I do that, I'm going to use this 3rd property where I see that there's a number out front. So I'm going to bring that up. So I'm going to bring that exponent up. So it is, let me keep that marker actually. So it's going to be ln e to the 6th raised to the 2nd power. So the base is the e to the 6th, but now I'm raising it to the 2nd power, and then minus ln e to the 5. And then I can get this power of a power, so I can multiply those. So it's going to be ln e to the 12th minus ln e to the 5th. And then ln e, that just cancels out because ln is the inverse of e to a power. So we just get 12 minus 5 here. And you could also look at this as like this has a base e. So if you look at ln e, this really means e to what power equals e, and that would be 1. So x would equal 1 here. So they cancel each other out. It's kind of a neat little thing. Ln of e is 1. So then 12 minus 5 is 7. And that would be evaluating that. So we're actually finding a value. Again, when you see that word evaluate, that means you're finding a value for that. So we're bringing that exponent up, multiplying that power, because it would be a power to a power, and then eliminating that ln e. All right, this one we're condensing. We're evaluating this, so we are going to condense using this rule in order to evaluate. So let's bring this here. All right, so what I want to do is condense this. So it's going to be log base 18 of 6 times 3. 6 times 3 because I'm using this property up here. So what this means is 18 to what power equals 18, and x would equal 1. So this is kind of like that property that I was just mentioning with the natural logarithm where you have ln of e is equal to 1. If you have log of a base, when you evaluate that, if the base and the exponent are the same, the value are the same, then the exponent is going to be 1. And that will always be the case. But you can see that logically too. This really just means 18 to what power equals 18, and that would be 1. All right, last thing, we're expanding here. Notice I have multiplication, so I'm going to write this as log a to the 8th plus log b squared plus log c. Again, so I'm going the opposite direction here. I'm taking this and breaking it up. And then I do see I have a couple of exponents too, so I'm going to use this rule here. So this is going to be 8 log a plus 2 log b plus log c. And that's an example of expanding. So we saw several different examples there. And again, this becomes useful when we want to solve problems. We can use some of these properties to help us condense and solve problems. All right, that's it for this one.